Hello, Algebra 2 students. Today we will be doing 8.6 notes, solve rational equations. The first type of problems that we are going to solve are the ones that involve cross-multiplying. They only work when you have one fraction on the left side of the equal sign and one fraction on the right side of the equal sign. So examples 1 and 2 you can do by cross-multiplying. Now, if you remember from geometry, if you have a fraction a over b is equal to another fraction c over d, you cross-multiply. So you would do a times d is equal to b times c. So you're always multiplying this way. Those two multiplied together equaling the other product. And so in this particular problem number 1, before we start multiplying, we want to list the restrictions because we are not going to show a complete check. We don't need to if we show our restrictions and we're careful. So looking at the first fraction on number 1, look at only the denominator. X cannot equal -1 in that denominator. Oops. And in the other denominator, for this one, x cannot equal -5/4. And the way I got -5/4 is I would set that denominator equal to 0, subtract 5 on both sides, and then divide by 4. I do it all in my head. And you could too, honestly, if you just know it's 4x plus 5 equals 0, subtract the 5, and then divide by 4. All right, so now we can cross multiply. So I'm just going to circle one of the cross products. Do you even have to? No, not really, but I'm going to. So 3 times 4x plus 5 is equal to 9 times x plus 1. Multiplying out the left side using the distributive property, 12x plus 15 equals 9x plus 9. Now I'm going to subtract 9x on both sides because I want the x's on the left side. Doesn't really matter. So we have 3x plus 15 equals 9. Subtract 15 on both sides. 3x equals -6. Divide by 3. Divide by 3. X equals -2. Before you box in your answer, check to see if it's not a restriction, what I wrote in green. X equals -2 is fine because it's not -1 and it's not -5/4. That is your answer. You don't have to do a complete check, especially if you're careful. Okay, now for problem number 2. So I will circle, this time I'll circle this cross product. Again, it doesn't matter. -12 times x plus 2 equals -6 times x minus 1. The left side will be -12x minus 24. The right side will be -6x plus 6. Add 6x to both sides. And I have -6x minus 24 equals positive 6. Add 24 to both sides. -6x equals 30. Divide by -6. X equals -5. Now we want to check those against our restrictions, which I just realized I did not write. So x cannot equal -2 in the first fraction, and x cannot equal a +1 in the second fraction. Because if they did, they would give you 0 in the denominator, which we cannot divide by 0. So x equals -5 is a valid answer. So we are good to go. All right. Life is great when you can solve a rational equation by cross-multiplying, but life is not always great. So if we look at problem set B, if you look at examples 3 and 4, we can't cross-multiply because there are more than there's more than one fraction on the left side of the equal sign, even though there's only one fraction on the right side, can't cross-multiply. So in that case, you follow the following steps. You factor the denominator if you need to. I never put that in step 1. Then you find the least common multiple. Multiply through the least common multiple to eliminate the denominators and solve. So here we don't keep the denominators because it's an equal sign. So the first thing we're going to do is, and we'll do each problem, look at problem number 3, check to see if the denominators can be factored. They can. You have a single variable, you have a number, but you have to still list the least common multiple, even though you don't need to factor. So the least common multiple in this problem is 4, because that's our number, and x appears once in any single fraction. So that's our least common multiple. This is what you do when you, and also let's list our restriction. X cannot equal 0. So you can have any answer other than 0 for problem number 3. So here's what I tell students that really helps you with this, with the equations. So you want to multiply every fraction by the least common multiple. So here's what we do. So, and I think it just makes sense to write it out. So you want to write it out. So you want to do 5 times 4x over x, and you only multiply the numerators. So multiply through the least common multiples to eliminate the denominators. Here's what's going to happen. So I'm going to write down 5, and then I'm going to, oops. Okay, so I'm going to multiply each of those by 4x. So I'll say 4x times 5 all over x plus 4x times 7 all over 4 is equal to, you remember you have that negative, so, but I'm going to put the 4x first. 4x times negative 9, and it's over x. Okay, now here's what happens. So we have 20x over x. So here's 20x plus 28x divided by 4 equals negative 36x divided by x. Here's the beautiful part. The whole point is to get rid of the denominators, and it happens, it works. X's cancel, you're left with 20. 28x divided by 4 is 7x. And look at this. Then you just subtract 20 on both sides. 7x equals negative 56. Divide both sides by 7. X equals negative 8. And check that answer against your restriction. Since it's not 0, you are okay, and it will check. So you're good on that one. We are going to do number 4. And so the first thing we want to do is check to see if any of the denominators need to be factored. They don't. 8 over x minus 5, that's linear. 3 over x. So you are ready to state your restrictions, which the restriction for the second fraction is x cannot equal 5. And for the third fraction, or the one on the right side, x cannot equal 0. Because you can't have 3 over 0. And for 8 over x minus 5, 5 can't be, x cannot be 5, because 5 minus 5 will give me 0. So we are ready to list our least common multiple. And it is x appears only once, and x minus 5 appears only once. There, for the first number 1, it's just 1 over 1. So that's nothing. So you want to multiply each fraction or each term by x times x minus 5, which is what I'm going to do. So for this one, I'm going to multiply the 1. I guess I should write this. I'm going to list the 1 first, and then I'm going to multiply it by x times x minus 5. Fraction number 2, I have the minus. So it's minus 8. And I'm going to multiply it by x times x minus 5. So and it has a x minus 5 as a denominator. And the last one, so put my equal sign. I'm going to multiply the 3 times x minus 5. And it has the denominator x. All right. At this point, if you've multiplied all your tops by the least common multiple, your denominators will cancel. So the first fraction is x times x minus 5, which is x squared minus 5x. Okay, take a look at this. X minus 5 in the numerator cancels the x minus 5 in the denominator, and you're left with minus 8x. On the right side, the x's cancel here. So this x cancels out that x, and you're left with 3 times x minus 5, which is 3x minus 15. Yeah. Okay, we see an x squared term, so we're probably going to have to factor, but let's combine like terms. We have x squared minus 13x equals 3x minus 15. It's best to move the right side over to the left side. So I'm going to subtract 3x, and I'm going to add 15. Put that right behind there. So we have x squared minus 16x plus 15 equals 0. Right. We do want to try and factor it before we try and use the quadratic formula. So let's make an x factor. Okay, b is negative 16. A times c is 1 times 15. So what are the two numbers that multiply, give you 15, added, give you negative 16, and be negative 1 times a negative 15. Because negative times a negative is a positive. Negative 1 plus negative 15 is negative 16. So we have x minus 1 times x minus 15 equal to 0. Now to solve for x, use zero product property, ZPP, set that equal to 0, set that equal to 0. So x minus 1 equals 0, x minus 15 equals 0. Add 1 to both sides, you get x equals 1. Add 15 to both sides, you get x equals 15. Check to see if either of those will be restrictions. They're not, because it's not x equals 5, nor it's x equals 0. So we are golden. Okay, moving on to the back two problems. So this is the one where we will have to factor. So we want to first factor the denominator, and hopefully you remember that these are nice numbers you can take the square root of. It's a difference of squares. So I'm going to, you want to write small here. So what I'm going to do, I'll still write small, but I'm going to make my screen bigger. So I have 6 over x minus 3 equals 8x squared over, factor that, and you have x plus 3 and x minus 3 minus 4x over x plus 3. You could put that in parentheses if it helps you. I mean, it's more than one thing. You could do that for all of these. There we go. And we want to state the restrictions right now. So x cannot equal a positive 3 in their first fraction. In the second fraction, for this right here, x cannot equal negative 3. And for that last one, x cannot equal negative 3, which we already listed. So these are our restrictions that we want to compare against. So I'm going to box these in. So it draws my attention to that. Now the next thing we want to do is list our least common multiple. So x minus 3 appears once. X plus 3 appears at most once in any fraction. And so that is our least common multiple. So we are going to multiply every numerator by that. So let's go ahead and do that. So I'm going to list my 6 over the x minus 3. That's the original fraction, but I'm going to multiply the top by x minus 3 times x plus 3. Equal to, okay, I'm going to list my 8x squared over x plus 3 times x minus 3. And I'm going to multiply that top by x plus 3, x minus 3. So our last fraction. So minus 4x over the x plus 3 that's there. And we are going to multiply that top by x minus 3 times x plus 3. All right, now the fun part, canceling. These cancel, and you're left with 6 times x plus 3. And I'm going to go ahead and do that math. You don't have to. You can just write out this step if you want, but I'm going to go ahead and do it. So 6x plus 18 equals, here lots of nice things cancel. X plus 3 cancels that, x plus 3, x minus 3. God, that looks so much nicer. Equal to 8x squared. And our last fraction, what cancels? So this stuff cancels right here. And you're left with 4x times, and you know what? If it helps, just write this out and then worry about it in a different step. You could have done that with that 6x plus 6 times x plus 3. So, and I might do that. All right, so now we have 6x plus 18 equals 8x squared minus 4x squared plus 12x. Okay, you can combine like terms on the right side. 8x squared minus 4x squared is 4x squared plus 12x. Okay, I'm going to move these two guys to this opposite side. So I'm going to subtract 6x, I'm going to subtract 18. So I want the left side equal to 0 because I want my ax squared term to be positive. So 0 equals 4x squared plus 6x minus 18. And now I'm going to make x factor. Okay, b is 6, a times c is negative 18. So two numbers multiplied together give us negative 18. Added give us did I do here? Okay, hold on one second. I feel like I did something wrong. So I have, oh, I know what I did wrong. Okay, I jumped the gun, got too ahead of myself. I can divide the right side by 2, or we can divide everything here by 2. Oops. So because 4, 6, and negative 18 is all divisible by 2. So we can divide, and it's an equation, so you can. So 0 equals 2x squared plus 3x minus 9. All right, we are ready to make an x factor chart. B is 3. A times c, this time I am going to write a times c, is 2 times negative 9, which is negative 18. And then two numbers that multiply give you negative 18, added give you 3 is 6 and negative 3. So that factors into, be really careful here. You guys should remember this. Remember, a is not 1, so you can't just put an x here. You have to put your a value, and a is 2. So put the 2x, so 2x and 2x in each slot, and then your factors, a positive 6 and a negative 3. And then you remember, you just need to reduce your fractions. So you can divide or reduce each of these binomials. So you can divide both of those by 2. So you have 0 equals x plus 3. And you can't divide the second one by anything. Okay, now set that equal to 0. This equal to 0. First one, x equals negative 3. But sadly, it's a restriction. So this is a no solution right here, because it is a restriction. Or it's an extraneous solution. The second one, so I'm going to do the work right here. 2x minus 3 equals 0. Add 3 to both sides. Divide by 2. 3 over 2 is not a restriction, so it is fine. Okay. And now we are going to do number 6. So number 6, the denominators look great. They're already factored, so we can list our restrictions. So for this fraction, x cannot equal 2. And for this one, x cannot equal 2 as well. Okay, so our least common multiple is just x minus 2. That's easy enough. So we are going to multiply every top by x minus 2. And I'm going to just do that just for simplicity's sake, I guess. So I'm going to multiply the 5x over x minus 2 by x minus 2. Equal, I'm going to multiply the 7 times the x minus 2 plus the 10 over x minus 2. And I'm going to multiply that 10 by x minus 2. Okay, now the fun part of canceling. Those cancel, and you're left with 5x. Easy. 7x minus 14. And these cancel, plus 10. So we have 5x equals 7x negative 14 plus 10 is negative 4. Please don't call it 24. It is a negative 14, not a positive 14. So now we want to subtract 7x on both sides. Negative 2x equals negative 4. Divide by negative 2. X equals 2. Or does it? X cannot equal 2 because it is a restriction. So no solution for this particular problem. And the reason why this is a restriction. It will give us a 0 in the denominator, which we cannot divide by. Okay, last problem. The cost of fueling your car for 1 year can be calculated using the equation fuel cost for 1 year is equal to the miles driven times the price per gallon divided by the fuel efficiency rate. Last year, you drove 12,500 miles, paid $2.15 per gallon of gasoline, and spent a total of $1,225.50 on gasoline. What is the fuel efficiency rate of your car? So let's plug in everything we know. So on the left side is the cost of the fuel for 1 year. So it was $1,225.50 equal the miles driven. So we 12,500 miles times the price per gallon, which is 2.15. And we have to solve for the fuel efficiency rate. And I'll call it R. There we go. And so this one, we can cross multiply because there's one fraction on the left side and one on the right. So remember, this is just over 1. So we can cross multiply. And we like that a lot. So I'm going to circle one of these cross products. So we have 1,225.50 times R is equal to 12,500 times 2.15, which I used a calculator and I got 26,875. Then I want to divide both sides by 1225.5. And I got a fuel efficiency rate of about, and I'm going to approximate it, 21.9 miles per gallon. That's how much, that's how many miles per gallon your car gets. This example. All right. Next problem, part B. How much would you have saved if your car's fuel efficiency rate was 32 miles per gallon? So let's see what the cost would be. So the cost is equal to, so fuel cost for 1 year, miles driven, so 12,500, because you're still going to drive the same number of miles. Price per gallon is still $2.15. But what if your fuel efficiency rate was 32 miles per gallon? So you do know R, but you don't know the cost. So you would multiply 12,500 times 2.15, so that's 26,875, divided by 32, and the cost is $839.84. That's how much money you would have spent on gas if your car got 32 miles per gallon. So let's see how much we would save. So we are going to take the $1,225.50 you paid for a year. Had you had a better car and got better fuel efficiency, so subtract that amount from the top amount. And would have been easier just to use a calculator. So $385.66 would have been your savings had you had a better car. And those are your notes for today. Have a great day, Algebra 2 students.